Hello everyone. Hope you are doing very well. Today, as you all know, that we are going to do the DNF block elements exemplar questions from our NCERT textbook. So let's practice and let's begin our today's topic NCERT chapter 4 DNF block elements, some exemplar questions to practice. This is disclaimer. Let's begin with our first question, which is a multiple choice question number 5. So the question is that on addition of small amount of KMNO4 to concentrated sulfuric acid, a green oily compound is obtained which is highly explosive in nature. So we have given a reaction explanation that when you add small amount of this KMNO4 into the concentrated sulfuric acid, you will get a green colored oily compound which is highly explosive in nature. Identify the compound from the following. So you have to identify that green colored compound that you are obtaining from the given options. The options are Mn2O7, MnO2, MnSO4, or Mn2O3. So you have to tell that which is the correct compound that is you are getting, which is very highly explosive in nature, while the reaction of KMNO4 to concentrated sulfuric acid. So try to remember the uses and the properties we have seen for the DNF block element compound, and the properties we have studied about the compound formed by potassium permanganate. Okay, so you have given some time, try to solve this, then we will see that which option is our correct answer. Okay, let's see. So for this given question, the correct answer is option first, that is manganese oxide, that is Mn2O7. When you add small amount of KMNO4 to the concentrated sulfuric acid, a green colored oily compound, that is for Mn2O7, is obtained, which is highly explosive in nature. Okay, so this oxide of manganese having the formula Mn2O7 is highly explosive in nature, and it obtained when you add this KMNO4 into the concentrated sulfuric acid. This is having a green oily color texture, and the reaction is when KMNO4 reacts with concentrated sulfuric acid, it will give us the Mn2O7, the green colored oily compound, highly explosive, plus the side products like KHSO4 and water molecules. Okay, so our correct answer is going to be Mn2O7. Let's move to our next question. So this is a multiple choice question marked as question number 6 in our NCERT textbook. The question is that the magnetic nature of elements depends on the presence of unpaired electrons. Identify the configuration of transition element which shows highest magnetic moment. So we have given this concept that magnetic nature, if you want to identify for such element, for an element, you have to first of all identify the number of unpaired electrons present in that particular element. Now you have given the option some configurations of the elements. So you have to select the correct configuration for transition element that is corresponding to the highest magnetic moment. The options are 3D7, 3D5, 3D8, or 3D2. So you are provided with some time try to solve this. Try to, remember the formula of the magnetic moment, how you find out the magnetic moment for an element. And after this time, we will see what will going to be the correct answer. Let's see. So for this given question, the correct answer is option second, that is 3D5. Now, to determine the configuration of transition element that will show highest magnetic moment, we need to analyze the number of unpaired electrons in each given electronic configuration. So in the options, we have provided different electronic configurations. And using that, you have to identify the number of unpaired electron that is going to be present in the D subshell. And then you have to identify the configuration of the transition element that is corresponding to the highest magnetic moment among the given options. So the magnetic moment is directly related to the number of unpaired electrons present in the element, with more unpaired electrons resulting in the higher magnetic moment. So they are like proportional, directly related. So if unpaired electrons are more in an element, its resulting magnetic moment will also be higher. Greater the number of unpaired electrons, higher will be its value of magnetic moment. Now, since we have different configuration from which one of the configuration is 3D5 and 3D5. So in the D subshell you can maximum fill the electrons as 10 number of electrons, right? If maximum number of filling of electrons in the D orbit in the D subshell is 10, then the half filled will be 5, right? That means the 5 number of unpaired electron is the maximum unpaired electrons that a D orbital can get. Okay, so we have a option which is given as 3D5. So 3D5 has 5 number of unpaired electrons in it, right? Which is maximum that can be attained via or in the D orbit. Hence, because it is having the highest unpaired electrons, which is 5, so it will be also having highest magnetic moment. Now, if you want to find out the value exactly, so magnetic moment is described as mu. Nu is equals to under root n plus 2, where n is representing the number of unpaired electrons in the Bohr magneton units. Okay, so this is the formula for measuring the magnetic moment. Now you just have to simply put the value of n, that is unpaired electrons, which is 5, right? For 3D5, n is 5. So mu is equals to under root 5 times 5 plus 2. 5 plus 2 is 7 and 7 times 5 is 35. So mu will become equals to under root of 35. And you can also write it in decimal as 5.95. Okay, because under root 36 is 6. So under root 35 will be close to 5 point something. So it will be 5.95 Bohr magnet. Okay. So the configuration of transition element that is showing the highest magnetic moment will be the configuration which is having the highest number of unpaired electrons. And here we have this as 3D5. So the 3D5 will be our answer. Let's move on to our next question. Now this is a multiple choice question number 8 in the NCERT textbook. Question is that which of the following reactions are disproportionation reaction? So you have to tell that from the given 4 reactions, which reaction are disproportionation reaction. And then you have to choose the correct option in which the correct number of the or correct representation of the disproportionation reaction is given. So A is saying the reaction as copper positive converting to copper 2 positive plus copper. In the B, we have 3 MnO4 negative plus 4 protons, giving us 2 MnO4 negative plus MnO2 plus 2 H2O. C has 2 KMnO4, giving us K2 MnO4 plus MnO2 plus O2. And in the D, we have 2 MnO4 negative plus 3 Mn2 positive plus twice of water molecules, giving us 5 molecules of MnO2 plus 4 protons. These are the 4 different reactions given. You have to identify the reaction which is disproportionation, and then you have to choose the correct option. So the option provided are A, B and C, B, C and D, or A and D. So you have to select the correct option. So you have given some time. Try to solve this question. Basically, try to, if a little hint will be, try to go on the basic concept of disproportionation. What is it? Okay. And then you can clearly solve it. And after this time, we will see that which option is corresponding to your correct answer. Okay, let's see. So for this given question, the correct answer is option A, that is the A choice, the A reaction. The reaction, if you go on the concept of disproportionation reaction, the reaction in which oxidation as well as the reduction is occurring upon the same atom simultaneously is known as disproportionation reaction. So in simple language, if you have given a reaction where a same atom at the same time undergoing the oxidation process as well as the reduction process, then that reaction is known as disproportionation reaction. Oxidation means that atom is undergoing oxidation process, means it is losing its electron and increasing its oxidation state. Meanwhile, reduction means it is gaining some electrons and converting from some higher oxidation number to lesser oxidation number. Okay. So in the same reaction, if the oxidation and reduction are happening with the same atom simultaneously, then that reaction is considered as disproportionation reaction. So you just have to use this concept or definition for disproportionation reaction and then apply to the 4 of the reactions given in the question and then identify the correct disproportionation reaction. So as you know, in the A reaction, copper positive is converting to copper 2 positive and copper. If you observe, the copper positive is converting to copper 2 positive, the plus 1 is converting to plus 2. The oxidation number is increasing. That means the oxidation is happening via losing of one electron. And on the other hand, with the same atom of copper positive, it is converting to copper 0. So plus 1 to 0, that means the reduction of the oxidation number is happening. That means by losing, or you can say by gaining an electron, the reduction process is happening and copper positive is converting to the copper in the 0 oxidation number, right? So in the same reaction with the same atom, oxidation reduction both are happening. So this reaction will be disproportionation reaction. Hence the A reaction given for copper positive to copper 2 positive plus copper will going to be our correct answer. Let's move on to our next question. This is a multiple choice question, number 9. Question is that when the KMnO4 solution is added to oxalic acid solution, the decolorization is low in the beginning, but becomes instantaneous after some time. Because so you have to give the correct reason that why this is happening, that when you add KMnO4 solution to the oxalic acid solution, the decolorization which is happening is slow in the initial time, in the beginning, but it will become instantaneous after some time. Why? You have to give the reason. The options are: carbon dioxide is formed as the product, reaction is exothermic, MnO4 negative catalyzes the reaction, or Mn2 positive acts as auto catalyst. So you have to tell that which option is going to be our correct reason for its decolorization process is slow in the beginning. So you have given some time, try to solve this, and then we will see the correct answer. Okay, let's see. So for this question, the correct answer is option 4. That is, manganese in the +2 charge act as auto catalyst. So when the potassium permanganate, that is KMnO4, is added to oxalic acid, that is H2C2O4, a redox reaction will occur where this potassium permanganate acts as an oxidizing agent. Oxidizing agent means it will going to oxidize others and get reduced itself. Okay. So when the reaction between KMnO4 and oxalic acid happens, redox reaction will occur and this potassium permanganate act as oxidizing agent. Now initially reaction is slow. Why? Because the KMnO4, which is acting as oxidizing agent and which contain the manganese in its +7 highest oxidation state, it needs to be reduced to manganese 2 positive. Okay, which is in the +2 oxidation state, right? So reduction will happen and it will act as oxidizing agent. Okay, and the reaction will be slow. Now this reduction process of converting of manganese +7 to manganese +2 takes time. Why? As it involves the transfer of electrons from oxalic acid to the KMnO4, and also the manganese is converting from its highest oxidation state to its lowest oxidation state shown by it. So the reduction process is going to take time as it involves the transfer of electrons from the oxalic acid. Now as the reaction will proceed, MnO4 negative is reduced to Mn2 positive. At the beginning, there is a limited amount of manganese 2 positive that is formed, which means the reaction rate will be, the reaction speed will be slow. Okay. So when the manganese O4 negative is start to reduce to manganese 2 positive and the reaction will proceed, in the beginning time, there will be a limited amount of manganese 2 positive that is formed. That means that our reaction rate is really slow. Once a sufficient amount of manganese 2 positive ions is produced from the manganese O4 negative, it start to act as a catalyst for the reaction. Okay. So manganese 2 positive, first of all, we are getting the manganese 2 positive in the reaction while the reaction is proceeding. And then when it forms in a sufficient amount, it starts to act as catalyst for the reaction. That means the time or the rate, which is now slow, until now slow for the reaction, because it is taking time for the reduction of MnO4 negative to Mn2 positive. Now, when Mn2 positive produced in the sufficient amount, it will act as catalyst and increase the rate of the reaction. Now, this is known as autocatalysis, where one of the product which is formed in the reaction, like here in this case Mn2 positive, and then it start to catalyst. It start to act as catalyst and catalyze the reaction itself and speeding up the reaction significantly. As more and more Mn2 positive formed, the reaction rate will increase dramatically and leading to a rapid decolorization of the solution after the beginning time of the reaction. Okay. So in the beginning time of the reaction, because the rate of the conversion of the manganese O4 negative to manganese 2 positive, the conversion of the reduction of Mn plus 7 to Mn2 plus is slow. So the reaction rate is slow, and that's why the decolorization is slow in the beginning. But when you have a sufficient amount of manganese 2 positive produced, then it will act as catalyst for that reaction and speed up that reaction. And then the rate will also increase dramatically, and also the decolorization happening will also be increase, a rapid increase. This is why after the initial slow phase, the decolorization become instantaneous. Okay. So after the slow process of decolorization, when you have got a sufficient amount of manganese 2 positive from manganese plus 7, then the speed of the reaction will become faster, because manganese 2 positive will act as catalyst, and this will going to lead to rapid decolorization of the solution, due to which in the initial phase, in the initial slow phase, the decolorization is slow, and after that the decolorization become instantaneous. Okay, so the correct answer was manganese 2 positive here will act as auto catalyst. Okay, let's move on to our next question. Yeah. So this is a multiple choice question which can have more than one option as its correct answer. This is question number 29 as per NCERT textbook, and the question is that transition elements form binary compounds with halogens. Which of the following elements will form MF3 type compounds? So we are saying that the transition elements form binary compounds. That means the transition elements will going to attack on two number of atoms to bind with them. So they will form binary compounds with halogens. Now, which of the following element from the options you have to select will form MF3, where F is saying the fluoride halogen, okay, fluorine. MF3 type compounds, which following element will form, that you have to tell. The options are chromium, cobalt, copper, or nickel. So you have given some time, try to solve this, and then we will see which option is going to be our correct answer. Okay, let's see. So for this question, the correct answer is the option 1 and the option 2, that is chromium and cobalt. Now, the halogen, that is fluorine, has its ability to stabilize the higher oxidation state. Okay, so fluorine has this ability. We have studied this in the properties of the formation of halides, which we have studied in the theory part, right? So the halogen, fluorine, has this ability to stabilize the higher oxidation state shown by the transition elements. Now, the transition elements like chromium and cobalt, they have their higher oxidation state, which form MF3 type compound, where the metal will be going to have +3 oxidation state, right? So the high lattice energy means the energy that is released when the solid ions form the gaseous ions. Okay, so the high lattice energy leads to the formation of the compound cobalt F3, because it is going to have 3 unpaired electrons with which the bonding will form, and high bond energy for higher covalent bond forms chromium F6. Okay, high bond energy means the energy that you are going to require to break the bond. That will be high for chromium F6, for chromium fluoride, and also the bonding that is forming as covalent bonding, that energy is going to be higher. So through that, the chromium fluoride form, and due to the high lattice energy, it will lead to the formation of cobalt fluoride. So the elements that are going to form the MF3 type of compounds, where F is fluorine and M is the element from transition element, is going to be chromium and cobalt. So these two are our correct answer. So let's move to our next question. This is a short answer type question, marked as question number 38 from the NCERT textbook. Now the question is asking that when a brown compound of manganese, let's say it is A, is treated with HCl, it gives a gas B. The gas taken in the excess amount reacts with ammonia to give an explosive compound C. You have to identify the compounds A, B, and C. A is a brown compound of manganese, and B is basically the A compound. When reacts with HCl, it will give a gas. That gas is B. And when you take the gas in excess amount and react it with ammonia, then you will get an explosive compound that is going to be C. So you have to identify what are A, B, and C. You have given some time, try to solve this, and then we will see the correct answer. Okay, let's see. So for this given question, how can you explain that? First of all, you have to explain the reaction. Like how the reaction is happening, right? What is forming after which, what is going to be the product. So when the brown compound of manganese, which is named as A, is treated with HCl, it gives chlorine gas, right? So when this manganese compound reacts with the hydrochloric acid, it will produce chlorine gas. So MnO2, which is our A, which is our brown compound of manganese. This is A. When reacts with 4 molecules of hydrochloric acid, they are going to provide us manganese chloride, MnCl2, and the chlorine gas plus 2 molecules of water. So we have given that B is the gas. So gas is chlorine here only. So B is chlorine. A is this compound of manganese, MnO2. Now, this chlorine gas in excess when reacts with NH3, that is ammonia, to give NCl3. So chlorine gas reacts with ammonia, give us NCl3, and also gives us the hydrochloric acid molecule. So C will be NCl3 compound. So A is MnO2, B is chlorine gas, and C is NCl3. So the brown compound of manganese, that is A, is MnO2. The gas you are getting when you treat the A with HCl is B, that is Cl2. And the explosive compound that you are going to get when you react the B gas with ammonia. So C is NCl3. Hence, this is going to be our answer, MnO2, Cl2, and NCl3. Okay. Let's move to our next question. Okay. The question is that ionization enthalpies of cerium, Pr, that means praseodymium, Nd, that means neodymium. So these elements have ionization enthalpies are higher than this Th, that means thorium, Pa, that means protactinium, and U, that means uranium. Why? So these three are belonging to D block, and these three are belonging to, okay, these three are belonging to the lanthanoids series, and these three are belonging to the actinoid series. You have to tell that these lanthanoid series elements having ionization enthalpy higher than these actinoid series elements. Why? So you have given some time, try to solve this, and then we will see the answer of it. Let's see. So for this question, this cerium, praseodymium and ND, that means neodymium, they are belonging to the lanthanoid series, whereas this thorium and Pa is protactinium and U is uranium, they are belonging to the actinoids family, right? Now, when the electrons start accommodating the 4f and the 5f orbitals, the 5f electrons penetrate less into the inner core, right? We have studied this, that in the lanthanoid series, the outermost electrons are filled in the 4f orbital. Meanwhile, in the actinoid series, the outermost orbital are generally filled in the 5f orbital. And if you compare between these two orbitals, when the electrons start in these two orbitals, the 5f electrons are penetrating less into the inner core. That means it is less in the distance from the nucleus as compared to the 4f electrons. So they are more effectively shielded nuclei in comparison to 4f electrons in the lanthanoids, right? So if you talk about shielding, the 5f electrons are effectively shielded nuclei in the comparison to 4f electrons in the lanthanides. Now, what will going to happen for this? So this leads to the fact that 5f electron experience reduced nuclear force of attraction, and hence they have lower ionization enthalpy than the lanthanoids, because the 4f electrons are more close to the inner core, that means to the nucleus. That means they will be going to have they will going to experience more nuclear force of attraction than the 5f electrons. So 5f electrons is going to experience reduced nuclear force of attraction, and due to which they will have lower ionization enthalpies than the lanthanoid series. So removing the 4f electrons will be difficult. Ionization enthalpy for these thorium, protactinium and uranium are lower than this cerium, praseodymium and neodymium that are from the lanthanoid, right? That's why ionization enthalpy for the lanthanoid series is going to be higher than the actinoid series elements. Due to this reason, that 5f orbital or 5f electrons are less less situated at the inner core. That means they are going to experience lesser or reduced nuclear force of attraction, because 4f orbital will going to be filled first, then 5f electron will come, and due to which the 5f electron, because they are experiencing lesser nuclear force of attraction, so the removal of electron from them is uh, comparatively easier from the 4f electrons. So they are going to show the lower ionization enthalpy. So actinoids will going to show lower ionization enthalpy, and the lanthanoids is going to show the higher ionization enthalpy. So that's the correct reason. Okay. So let's move to our next question. This is a short answer type question, marked as question number 42. So the question is that although zirconium belongs to 4D and hafnium belongs to 5D transition series, but it is quite difficult to separate them. Why? So we have been asked about the zirconium and hafnium, that if zirconium is belonging to 4D and hafnium is belonging to 5D transition series, still why it is quite difficult to separate these two? You have to tell the reason. So you have given some time, try to analyze this question. Then we will see, or then we will conclude to its answer. Let's see. For this question, we know that due to the lengthenoid contraction, the gradual decrease in the size we have been observed in the lengthenoid series. So due to the lengthenoid contraction, poor F orbital shielding leads to an increase in effective nuclear charge. And due to this lengthenoid contraction and poor F orbital shielding, it will going to lead the increase in the effective nuclear charge, which reduce the size of hafnium, right? And due to which atomic radii of both zirconium and hafnium are similar, which means they have similar physical and chemical properties, and due to which their separation becomes difficult. Okay, so this is the correct explanation. You can add more points to it if you want, by explaining the lengthened contraction, by explaining how it is experiencing the poor F orbital shielding. Okay, so basically, due to the lengthened contraction, the decrease in the size or gradual decrease in the size of the elements are there in the lengthenoid series, and also due to the presence of the poor shielding effect shown by the F orbital, due to which the outermost orbital are going to affect by the nuclear charge increasing, and this is going to decrease the size of the element, that is hafnium. And due to this, the atomic radii of both the zirconium and hafnium are similar, right? And if their atomic radii is similar, they are going to behave similar, like physically and chemically. So their physical and chemical properties have been similar, and due to which their separation will become difficult. Okay, let's move to our next question. This is a short answer type question marked as question number 47. Question is that the second and third rows of transition elements resemble each other much more than they resemble the first row. Explain why. So we are saying that second and third row, that means 4D and 5D series of transition elements, they resemble each other much more than they resemble the first row, that is 3D series. Why is it so? You have to explain. So you are provided with some time. Try to analyze this question. Then we will see what will going to be its correct answer. Okay, let's see. So for this given question, due to the lengthenoid contraction, again, the atomic radii of second and the third row transition elements is almost same. So in the 4D and the 5D series, due to the lengthenoid contraction, the gradual decrease in the atomic size, the atomic radii of the second and the third row of the transition elements is going to be almost same. And that is why they resemble each other more as compared to the first row element, that is 3D element, and they will show similar character from the 4D and 5D series. Okay, so the correct reason is the lengthened contraction, the gradual decrease in the atomic size between the second and the third row transition elements, due to which their atomic radii will be almost same, and due to which they resemble each other much more compared to their resemblance to the first series, that is the 3D series, the first row elements. Okay, and that's why they are going to show similar character, similar property. Okay, let's move to our next question. This is the long answer type question marked as question number 67. Question is that on the basis of lengthenoid contraction, explain the following. We have given five choices, for each choice you have to explain it on the basis of lengthenoid contraction concept. The first is nature of bonding in La2O3 and Lu2O3. Okay, La is basically lanthanum, Lu is basically lutetium, the first and the last element coming in the lanthanoid series. So their oxide the nature of bonding, you have to explain using lanthanoid contraction. Second, trends in the stability of oxo salts of lanthanoids from lanthanum to lutetium. Third, stability of complexes of lanthanoids. Fourth, radii of 4D and 5D block elements. Fifth, trends in the acidic character of lanthanoid oxides. So you have given some time, try to analyze this question, and then we will see the answer of each and every part. Okay, let's see. So for this given question, let's start with the first part. So lanthanoid contraction effect. Due to the lanthanoid contraction, ionic radius of lutetium 3 positive is significantly smaller than that of lanthanum 3 positive. Okay, why? Due to the lanthanoid contraction. Lanthanoid contraction is basically gradual decrease in the atomic or ionic size of the elements coming in the lanthanoid series. Okay, and due to this fact of lanthanoid contraction, the ionic radius, if you compare of lutetium 3 positive, this is going to be very smaller than that of lanthanum 3 positive, because lutetium is coming at the end of this lanthanoid series and lanthanum is like the first element, right? So due to the lanthanoid contraction, the lutetium 3 positive ionic radius is significantly smaller than the lanthanum 3 positive ion. And the second thing is polarizing power. If you have a smaller lutetium 3 positive ion, this is going to have a higher charge density, right? Because the size is smaller, the charge density will be more, and thus it will going to have greater polarizing power on the O2 negative anion compared to the large lanthanum 3 positive ion. Okay, so we are talking about here the polarizing power, which is greater at like smaller lutetium 3 positive ion due to its high charge density. So it is going to be having greater polarizing power on the oxide ion, anion, as compared to the larger lanthanum ion. Bonding nature, if you talk about, increased polarizing power leads to lutetium oxide having more covalent character than the lanthanum oxide. Okay, so if you compare, the polarizing power is more over the oxide anion of lutetium because it is smaller, it has higher charge density. It can easily get attacked with the anion of oxide, right? And get like make stable bonding, and it is going to have higher covalent character. Now, if you compare with lanthanum has larger size, so it is going to have comparatively larger, smaller polarizing power on the oxide anion, due to which lanthanum oxide which form will going to be ionic. That means sharing will not happen. Here the donating and the accepting of the electrons will happen between the lanthanum and oxygen molecule atoms while forming the bond between them. Okay, so the covalent character of the lutetium oxide will increase due to the increased polarizing power. Then the lanthanum oxide, which is predominantly ionic in nature, the bond will form which is ionic. Now let's explain the second part, that is the trends in stability of oxo salts of lanthanoids from lanthanum to lutetium. If you talk about the decrease in cation charge, so due to the lanthanoid contraction, you have to use the lanthanoid contraction in every explanation of these 5 parts. Okay, so due to the lanthanoid contraction, size of lanthanum 3 positive ions decrease from lanthanum to lutetium. Lanthanide 3 positive ion, the ions which are shown by lanthanide series, that is going to be decreased from lanthanum to the lutetium the first element to the last element due to the lanthanoid contraction. Increasing polarizing power. Now, this decrease in the size from lanthanum to lutetium leads to the increase in polarizing power of lanthanoid ions from lanthanum to lutetium, right? Now, decreasing oxosalt stability. Due to the strong polarizing power of smaller lanthanoid ions, that means towards the lutetium if you are going from lanthanum, this is going to be increasingly distorts the electron clouds of oxo anions, which is weakening their internal bonds and thus decreasing the thermal stability of oxo salts from lanthanum to lutetium. Okay, so we are talking about the oxo salt stability because in the second point we are seeing we are talking about the stability of oxo salts of lanthanoids from the lanthanum to lutetium. So, due to the decrease in the size due to lanthanoid contraction, polarizing power will increase for the lanthanoids tripositive ions. And due to the stronger polarizing power of tripositive smaller ions, it will increasingly distorts the electron cloud of oxo anions. The distortion of electron clouds of oxo anions weakens their internal bond, and thus it will decrease the thermal stability due to the weakening of internal bond of oxo salts from lanthanum to lutetium in the lanthanoid series. Now let's see the third point, that is stability of complexes of lanthanoids. Now decreasing ionic radii. So we know that due to the lanthanoid contraction, ionic radii of lanthanoids ions, tripositive ions, progressively decrease from lanthanum to lutetium. Now the charge density will increase, and due to the decrease in the size due to lanthanoid contraction, with the same +3 charge, it will going to gradual increase in the charge density of lanthanoid 3 positive ions, right? So because the ionic size of tripositive ion shown by lanthanoids is decreasing due to the lanthanoid contraction, within the same charge, there's +3 charge. It will going to lead to a gradual increase in the charge density of lanthanoid ions. And higher the charge density enables the smaller lanthanoid ions to attract the ligands more strongly and can bind through various number of ligands, resulting in a progressive increase in the stability of their complexes from lanthanum to lutetium. Because complexes, when it will form when the element is going to attach with the different number of ligands towards with itself, right? So because the size is decreasing due to lanthanide contraction, charge density is increasing from lanthanum to lutetium, and this is due to which the complex stability will increase, because higher charge density enables the smaller lanthanoid tripositive ions to attract more number of ligands strongly, which will going to result in the stability or increasing stability of the complexes shown by or formed by the elements from lanthanum to lutetium in the lanthanoid series. Now let's see the fourth point, that is radii of 4D and 5D block elements using the lanthanide contraction. So what is the expected versus actual trend? So normally the 5D element are expected to be significantly larger than the 4D, which counterparts due to an extra electron shell. Okay, because from the 4D to 5D an extra electron shell added, due to which normally the 5D elements are going to be expectedly larger, significantly larger than the 4D counterparts due to an extra electron shell. However, due to this lanthanoid contraction occurring, their radii will become almost identical, right? This is going to be the radii relationship between the 4D and the 5D block elements, that due to lanthanide contraction, expected is that their 5D radii will be significantly larger than the 4D due to the extra electron shell addition. But due to the lengthenoid contraction presence, the radii will become almost identical from 4D to 5D. Lengthenoid contraction impact. So the 14 lengthenoid elements whose 4f orbitals are poorly shielding, they are filled before the 5D series. Okay, starting from hafnium. And this is going to cause a cumulative increase in the effective nuclear charge, which is going to experience by the subsequent 5D elements. Okay, so what is the impact of lengthenoid contraction over the 4D and the 5D block elements? That the 14 lengthenoid elements whose 4f orbitals are poorly shielding, they are filled before the 5D series. 4f orbitals are filled before the 5D series, which is starting from the hafnium. Okay, this filling of electrons. Now, this is going to cause a cumulative increase in effective nuclear charge. The nuclear charge is going to be effectively increased, which is experienced by the subsequent 5D elements. This nuclear charge increase is experienced by the 5D elements. And compensation of size. So this strong nuclear pull effectively counteracts the expected increase in the size, because we were expecting that 5D elements will going to increase its size, but this nuclear pull increase due to the lengthenoid contraction, which is going to counteract with the expected increase in the size of the 5D elements, resulting in the 4D and 5D elements in same group having remarkably similar atomic and the ionic radii. Their radii will become identical. Now let's see the fifth part, that is trends in the acidic character of lengthenoid oxide. How you can explain it using lengthenoid contraction. So decreasing cation size and increasing polarizing power. You know that due to the lengthenoid contraction, the lengthenoid tripositive ion size is decreasing gradually from lanthanum to lutetium, which is leading to the increase in their charge density, and also the polarizing power is also increasing. Increase covalent character, and due to this stronger or increasing polarizing power of smaller tripositive ion of lanthanoids, it will enhance their covalent character of lanthanum oxygen bond in their oxides from lanthanum oxide to lutetium oxides. So the covalent character will increase from lanthanum to lutetium oxides in the lanthanoid series due to the increasing polarizing power, which is going to be there because of the lanthanoid contraction or decrease in the ionic size. Then acidity trend will be that the acidic character consequently of the lanthanoid oxides will increase, or their basic character will decrease, you can say both, progressively from lanthanum oxide to lutetium oxide. Okay, they are interrelated, that when the lanthanoid contraction is happening, their ionic size is decreasing, due to which the charge density and the polarizing power is increasing along the lanthanoid series. And due to the stronger polarizing power, the covalent character from the lanthanum oxide to lutetium oxide is increasing, due to which the acidic trend, if you observe, along the lanthanoid oxides will increase. Okay, from lanthanum to lutetium, or you can also say basic character will decrease. So this is how you can explain each and every part or 5 parts of this question using on the basis of lanthanoid contraction concept. So you just have to interrelate the given statement with the lanthanoid contraction concept. Okay, thank you so much. That's all for today's chemistry session. Thank you.